So in this tutorial we're going to be looking at sensitivity analysis, and essentially that allows you to look at how a measured value is affected by changes to the model. So we're going to load in this hand pump assembly, and that's in hand pump sensitivity folder. So we'll just bring that in. And there it is. And essentially what we're going to look at is we're going to look at how the volume that this pump can pump in a single stroke is affected by dimensional changes in this link here, in the length of the handle, and in the distance between this hole center and this hole center here. And we're going to graph these values so that we can see how they change as these values are varied. So we're going to do a little bit of setup first. We're just going to make sure that all the datums are switched off. We're going to change some filters in the tree filter options. So if you want to go in there and just select features, we need the features visible, and then we're going to go into the analysis tab, and we're going to run a sensitivity analysis. So that's up here, and then we're confronted with this new window, and what we're going to do, we're going to pick a dimension from the model. So we're going to select dimension, and then we're going to pick this link from the model, and as we pick it you can see that some of the parameters that are driving that link become visible. And the one that we're going to vary is this length one, which happens to be 8 mm at the moment. So if we click on there, you can see that we've grabbed that and put that in the box. And what we have to do now is we have to set a lower and upper limit between which we want to vary this value. So we've done it between 6 and 10. The number of steps that we want between those two we have set as 10, and that's okay. So we're just going to hit compute and let the machine analyze how that change in length affects the volume pumped. So if you have a look at this, here's the sensitivity plot. It's now completed, and you can see that we have our starting volume down here, 25.5, and as we vary the link length, you can see that it varies up to just above 29 there. So that gives us a rough indication of how much changing that link length affects the volume pumped. And if you look at the tutorial, they've worked out the change in volume as a percentage, and they inform you that it's around 7% that this change in link length affects the overall volume pumped. So let's close that one down, and what we're going to do now is we're going to vary the handle length and see how that affects the volume pumped as well. So again, we're going to set this up very much the same. Sensitivity analysis, we need to select. We got our little entry window here. We're going to select dimension again. This time we're going to select the handle. You can see that the driving dimensions for the handle become visible. This time we're going to select this 20 mm that corresponds to the length of the handle. You can see that we now have that in our little collection box here. Now the default range has defaulted to 18 to 22. We're happy with that. The number of steps at 10, we're happy with that as well. So let's hit compute and let it generate the graph for us. So it's just calculating now, and there's the graph. And again, we could calculate these values in terms of percentage of, if this was 100% where we began, what does this value correspond to? But that's actually told to us in the tutorial text again, and they inform us that there's a 10% variation. So obviously varying the handle length has more of an effect than the link length that we looked at initially. So again, let's come out of that sensitivity analysis. And this time we're going to perform another sensitivity analysis, but this time it's going to be based on the location of this this hole where the link mounts. So we're going to vary the position of that hole, and in order to get access to that parameter, we have to actually look inside the handle part. So if you find the handle in the model tree here, we have to go inside the hole that we want to vary the position of is this second one, I believe. So if we select dimension and just select that second hole, you can see that it is. Currently it's 7 mil from this first hole, and we're going to vary this between 5. If we can enter 5 there. We haven't quite selected that. Let's try and select it again. There we go. Pin handle. And we're going to vary that between 5 and 10. And again, we hit compute. The machine takes a few seconds to generate the graph. If you have the graph on your screen, you can see the plot points appearing on the graph as the system runs through each variation of the part and then calculates the volume using these analysis features down here. So you can see the volume calc one at the bottom of the feature tree there. These have obviously been set up previously, and that allows us to get a figure for the volume. So here's our graph, and if we look at this and read the text in the tutorial there, it's telling us that there's a 50% increase when we vary the length of the handle here. So you can see we started at this level, and once we get up to this level we're at 150% of the starting level. So there's a 50% variance there. So from that we can assume that the design is very sensitive to the position of this hole in the handle, and if we were to target an area to vary to affect the volume, if we wanted to have the maximum effect, then we would vary the location of that pinhole. So that's essentially what sensitivity analysis allows you to do. It allows you to see how sensitive the model is to changes that you make, and normally you would run this in conjunction with an analysis feature like the volume calculation here to allow you to see how varying parameters in the model affects this analysis feature. So how sensitive the analysis feature is to the variances that you're making to the model.